Okay, great. So now we are going over graphing without technology, using some strategies. This is for IM2 Graphing Quadratics. And so and I'll list over here, this says graph the quadratic equation. Let's see if I can get this thing to work. Okay, see if it's going to work for me. No, how about that? Okay, so we'll forget the drawing pad. We're still learning that. So we'll go to drawing here. Okay, graph the quadratic function. Be sure to show at least 5 points. Okay, so let me move to this so I can move our problem around, and I need to zoom out a little bit so we can see everything. Okay, so we'll go back to our drawing tool. So now let's talk about, I'm going to erase this little part because it's right in the way. So let's go to the points that we want to find. We want to find the zeros. Okay. And if you remember, zeros, that's where the quadratic intersects with the x-axis. And there are going to be 2 points. And you're going to have a value for x, but then your f of x is going to be 0 every time. So you're going to have two ordered pairs, 2 points here, where the y value or f of x value is going to be 0. So this for zeros will be 0. So we'll do that first. And so we will rewrite this as 0. And remember, the reason is because this is your f of x axis. This vertical axis is f of x. And this horizontal axis is your x-axis. And when your f of x equals 0, you're down here at 0. You're on the x-axis itself. Your point is going to be along the x-axis somewhere. Okay, so I'm just kind of dotting it in just to reemphasize. That is where y or f of x equals 0. So when we say zeros, we're going to make f of x 0. And so instead of writing f of x, we're just going to write 0. And then we'll just copy everything else. Okay, so now we want to solve this for x. And so we're going to follow the order of operations when we solve for x. Actually, we're not going to use PEMDAS just yet. We're going to use property of algebra. And so we're going to either add, subtract, multiply, or divide to try and get x by itself. And so I have -2 next to a parentheses, so that's multiplication. And then I have adding 3. And so in this situation, what would you do? Would you divide by 2? Because you need to undo whatever operation. So this is multiply, and then the opposite of multiplication is division. So you can divide by -2, or you can subtract by 3. Which one do you think you should do? Not in this situation, because you want to get rid of any numbers that are being added on. So when you divide, it's a much simpler situation. So I would subtract 3 from both sides. Over here, I would put -3 plus 0, and that would give me a little bit simpler situation. So now I'm gonna have -2 x minus 6 squared, and then -3 plus 0. That's -3. Okay, and so now, Justin, now you would divide out the -2. So this whole thing divided by -2 on the right side, and then whatever you do to one side, you have to do equally to the other side. So that's multiplication property of equality. Even though you're dividing, we still say it's multiplication property. And this -2 and this -2 divide to be 1, and so over here I've got a negative divided by negative, which makes both of these a positive. And so I have a fraction 3/2, okay, equals yeah, because look, when I divide by, so let me finish copying this down. So when I divide by -2 right here, I have to do the equal operation. Yeah, I have to do it over here, and that does create a fraction. Okay. Okay. So right here I have the binomial x minus 6, and so what that means is that it's squared. So that means what we have is x minus 6 times x minus 6. Okay. We could look at it that way. Okay. Or here's another way, and this is probably what I prefer to do. Instead of writing out the binomial like that, I might just take the square root of both sides. So it's been a long time since I've done this, so I'll have to check my answer with decimals to look at the final graph. But I'm probably going to take the square root of both sides here, and that would leave me with the inside of this. So this square root, I'll put it in a different color. So this square root over here, let me trace it, is the inverse of the exponent 2. And so they negate one another. And so what was left? If they, yeah, so we have x minus 6. And so, and then I'm going to take the square root of this side over here. And this one's a little tricky because and I'm going to discuss some issues here. When I do a simpler version of 3 over 2, I'm going to have 2 times 2. That could be positive 4. Okay, that's 2 times 2 squared. 2 squared is 4. But also, when I do -2 times -2, that's also positive 4, right? And so when I try to go the reverse process and take the square root of 4, well, I know that the number value is a 2, but I don't know if it was a positive 2 being squared to get the 4, or if it was a -2 being squared. So it could have been positive 2 to the second power. That would be 2 times 2 is 4. Or I don't know, it could have been -2 to the second power. That gave us -2 times -2, which is also positive 4. So when I take the square root of a number, I need to include positive or negative. These are called roots. And so I need to account for that. This could have been positive or negative. And so when I do that, I need to say it was positive or negative. So this is going to be positive or negative. Okay. We do that every time when we take the square root of a number and we don't know what its root value is. They didn't give us any definition. Sometimes they'll say in these problems, roots are only positive, okay, or for all values of x that are greater than 0. In that case, it would just be dealing with a positive. Okay, so then I'm going to leave these here, and I'm going to do a little bit of side work over here. I'm going to root 3 over root 2, and I'm going to do some work because there's a convention in math where you don't want to have a square root of 2 in the denominator. So right here I have a square root in the denominator. And so I need to rewrite this in simplest terms means you don't leave a square root. It's just a math convention. It's just a rule. And so in order to do that, we need to do what's called rationalize the denominator. And so really what that means is we need to change this from an irrational number, which is square root of 2 is an irrational number, and we need to change it to a rational number. So we are going to take the script. Okay, so that's a great question. So rational numbers are numbers that that terminate and they repeat and they terminate. Irrational numbers are numbers that do not terminate and they do not repeat. So for instance, whole numbers are included in the set of rational numbers. So, keep going. Okay, and then 0, let's go negative. Those are rational numbers. So sometimes it's easier to talk about what an irrational talk about rational numbers and what they are and what they are not in order to define what a rational number is. So these are all considered rational numbers, negatives, and those kinds of numbers, and then so on and so forth. Also, numbers that are between 1 and 0, like fractions, like 1/2. That terminates at 0.5. Okay, so that's a terminating fraction. That's rational. And then you'll have another fraction, 1/3. This is between 0 and 1. So we're talking about numbers that are close to 0, in between 1 and 0. So that's a non-terminating repeating, and that's considered rational as well. The 3 just keeps repeating. That's rational. So let's talk about numbers that are not rational. Well, let's talk about the number pi. Pi is a ratio between a circle's circumference, the distance around the circle, and its diameter. So it's circumference over diameter, and that's what pi is. Okay, and so when you start talking about a number like that, it's a non-terminating, non-repeating. So it doesn't have a repeating pattern to it. 3.14159. You still have this memorized several, and it doesn't repeat. It just kind of keeps going in a non-repeating, non-terminating fashion. And so square root of 2 is considered irrational because it's a non-terminating, non-repeater. And this is approximately 1.7. Now let's see if I look it up on the calculator. Let's see. I'll just type calculator really quick. Calculator. Bring up a calculator. And if I take the square root of 2, you'll see it stops here at 7, but it really keeps going. 1.414213562337, and so on. It doesn't, nothing repeats. Like you don't get a 4-1, 4-1, 4-1, 4-1. You just don't get that. So, for instance, if we did like 11 divided by 7, that looks to be irrational, except, let's see, 571428. So this one repeats this section. So this one's considered rational because this one rounded to 3 right here. But basically this 1.571428, that repeats. It doesn't terminate, but it repeats. And so that 11 over 7 is considered rational. So it's a little bit of number theory there for you. But when we do our math, we need to, and it's a math rule, we don't want to leave a square root in the bottom. We want a rational number in the bottom. We don't want a square root of a number. So anyway, okay, so then we do that by multiplying by the denominator here over itself, which is basically, and I like to do this with some students, and I'll do it here just because we're talking about it. A number divided by itself is 1. And guys, it's not a very good 1, but that is the square root of 2 divided by square root of 2 is 1. And this number right here, square root of 3 over square root of 2 times a 1 will just be the square root of 3 over square root of 2. The difference is that we're going to change the way it looks, and we do that for a lot of different reasons. Basically, we want it to be simplified. And so when we work on these problems, we're making things a little bit more clear for our next steps. So up here, I'm just going to multiply -3 times, square root of 3 times the square root of 2, and that's the square root of 6. I don't know if you remember your rules here, but you basically multiply the numbers and you keep the square root over it. And in here, I have the square root of 2 times the square root of 2, and then I wind up with a perfect square, because a number times itself will become a perfect square. So now I have the square root of 6 divided by the square root of 4. And so now I'm just going to keep moving down. I'm actually going to give myself a little more space here. I'm going to draw a line here because I don't want to go past, and then we'll come over here and do it over here. So I know that I can take the square root of 4. The square root of 6, it doesn't simplify anymore. It stays at square root of 6. And then the square root of 4 down here, that becomes, okay. So what I've done is I've gotten rid of the square root in the bottom. I've rationalized the denominator. And so that's what we do. So I'm going to come back here and I'm going to put my new, the new version of this, I'm going to put down here. And you'll notice the only difference, it's the same amount. The same square root of 3 over 2 is the same amount as the square root of 6 over 2. The difference is I've rationalized the denominator, okay? And then remember we had positive or negative because we don't know if this was originally, the root was positive or negative. So we'll include both. Okay, so now, hang on a second, I'm getting questions here. You'll be able to use it, hang on just a second, I'll pause the meeting, he's worried. So, okay, so now that we've talked about that, I need to get the x by itself, which means I only want x here. So Justin, what do I need to do up here in this problem? What do I need to eliminate to only have x here? So it's a negative 6. So what's the inverse of negative? That's right. So I'm just going to add positive 6 over here. And if I add positive 6 over here, I need to put a positive 6 over here. And so it works for me to put the 6 in front of the options plus or minus square root of 6 over 2. Okay, so negative 6 and 6, they add up to be 0. We can cross those off, and I'm down here at x. Okay, and so I'm left with the answer 6 plus or minus the square root of 6 over 2. And so I know that I need to graph that, and so I need to do a little bit more simplifying. Okay, this is a ton of work, but it'll pay off. So I want to get rid of the 2 down here. So I'm going to multiply in order to add these. So this here is 6 over 1, and I need to find a common denominator. And so I am going to multiply 6 over 1 by 2 over 2. And so this is some more fundamental math skills here that are coming into play in our algebra. So here I have 2 times 6. That's 12. And then I have 2 times 1. That's 2. And so I have 12 plus or minus square root of 6 over 2. And I'm going to put the x equals here because it's easier to go left to right. And so really, if I were to rewrite this even simpler, this would be 12 plus or minus the square root of 6 over 2. So kind of see where I'm going here with this. Now, at this point, I've done everything that I can. I can't simplify anymore. I wouldn't divide this out because this is, think of this up here as in parentheses. Okay, so PEMDAS comes into play when you have a division bar under addition. So you cannot, you can't combine those, or you can't divide by 2 unless you divide the whole thing by 2, which in this case we wouldn't do that. So, but what I can do is I can write, since I have 2 operations here, plus or minus, I'm going to do that. I'm going to have 12 plus the root of 6 divided by 2, okay, or 12 minus the root of 6 divided by 2. And at this point, I need to estimate what the root of 6 is. And since my scale up here on the graph is by 1s, I'm going to round it to probably the nearest 10th place. So let's go back to the calculator. We'll use our calculator here. Look it up really quick. Calculator. Okay, so now I want to do the square root of 6, and we're going to round it to the nearest tens place. And you can see square root of 6 is not rational, so I'm going to say 2.4, because there's my 4 in the tens place, and then there's a 4 in the hundreds place. And if that was a 5 in the hundreds place, this 4 would be 2.5. But right now it's going to stay at 2.4, so jump back to the work I was doing. So this becomes 12 plus 2.4 over 2. And then this one becomes 12 minus 2.4 over 2. So if I were to do 12 plus 2.4, that would be 14.4 over 2, which I can do that in my head. That's 7.2. That's 7.2. That's one of my zeros right there. Okay. And then if I did 12 minus 2.4, well, 12 minus 2, let me think about this. We'll do a little thought bubble up here. Okay, 12 minus 2 is 10. That's 10. But my 2 doesn't look very good there, but that's a 2. And then I have to minus 10 minus 0.4. Well, that's 9.6. So this is going to be 9.6 over 2. And I'm going to do that on my calculator. So let's jump back over here. We'll clear it out. 9.6 divided by 2. 4.8. Perfect. So I know that this 0 is at 4.8. And so all that work right there is going to be my 0. So up here I have, well, let's see. I have 7.2 comma 0 and 4.8 comma 0. So here I won't use up any space. I'll just put it in here the best I can. And let's see, I'll put it in thinner. And again, I have a bad memory. So 7.2 would go right in here. 7.2, and what did I say? 4.8? 4.8. 4.8. Okay, so that's a lot of work, and I've used up a lot of working space on that. So now here's what I'm going to do. I'm going to block off some of this space here. Let's see. Let me bring this back up to 1. And so I'm going to block off some space right here. We can work on the rest here in a second. So let's just put the 7.2 and 4.8 onto the graph here. So let me clean up our graph a little bit, because I was just trying to make a point there earlier. Oh boy, I shouldn't have made so many dots. I should have just made a line. Wow. I'm learning a lot every day about what to do and what not to do. So okay. All right, so here we are. Okay, so now I am going to put those two in black. So 7.2, 7.8 first. So 1, 2, 3, 4 is right there. And here's 5. So I'm going to put 4.8 like right here. 4.8. Okay, and then the other one is 7.2. That's 5, 6, 7. And here's 8 right here. So 7.2 is going to be right around in there. Okay, so now we can find a couple of other things. We can find 5 other points. We found the zeros. We can find the vertex next would be great. Okay, so the vertex. Okay, so if this equation was in standard form, we could put this in standard form. We could use negative b over 2a. I think that's it. But this thing is not in standard form. So another thing we could do is just find the difference between 7.2 and 4.8. We could do that. 7.2 minus 4.8. Those are our two zeros. We could subtract that. Okay, and then that would give us our line of symmetry. Okay, and the reason we would find our line of symmetry is that the vertex is on the line of symmetry. So I'll go back to our calculator and I'll do 7.2 minus 4.8, and that gives us 2.4. Okay, so then 2.4, sorry, now I'm jumping around a little bit. So that equals 2.4, and what that means is I'm going to add 2.4 to 4.8, and that'll give us like in between here. So now I'm going to do 4.8 plus 2.4. So, so that gives me the distance between these two right here. And so actually, I need to, in order to find the halfway mark, I need to find what's half of 2.4. So I forgot. So really, I forgot a piece. This is divided by 2. And so this would be divided by 2. And that would be 1.2. So then I need to, so this part right here, the distance of that is 1.2. Okay, so let me make that in red. So if I were to add 1.2 to, what is that, 4.8, I would find the line of symmetry. So now I am going to do that. I am going to add 1.2 plus 4.8. Okay, and so that's going to be, I know that's going to be 6. Okay, so my line of symmetry is 6. It's going to actually be f of x equals 6. I wanted to write it all out that way. So here is 6, so it would be actually be right here, just like we were showing. I'm going to erase this, and I'm going to write the, and then we're going to probably not, we're going to run out of time here, but I'll get you as far as we can, because I do have to give the computer to my youngest. So basically, this is the line of symmetry. Okay, and we'll just keep going here. I'll work as quickly as I can. Okay. And I'll probably have to render this video later. And so that's your line of symmetry. Okay, so this parabola, it mirrors. This is like a mirror for the parabola. Okay, so now if we were to look at this, look at the lead coefficient right here. Is that a positive or negative 2? Negative 2. So this parabola is going to maximize. It's going to have a vertex that's above the x-axis and it's opening downward. And so I just need to be aware of that. And so now in order to find the vertex, I'm sorry, I made a mistake here in calling this f of x. This is not f of x, this is x. This is x equals 6. Okay, so in order to find the vertex, I'm going to take 6 and I'm going to plug it back into the original equation. So this is x is 6, so it's going to be not f of x, but f of 6 is equal to, and I'm going to rewrite the whole thing, but instead of putting an x in there, I'm going to substitute x for 6 for x. So, and you can see kind of what's going to happen here quickly. And we're going to follow PEMDAS now, which means if I follow PEMDAS, I am going to do parentheses first. So inside the parentheses, I have 6 minus 6. What's 6 minus 6? What's and so we'll rewrite that. Okay, rewrite everything. Okay, so we have f of 6. Okay, so what's 0 to the second power? Because that's exponents. Yeah, we're dealing with 0. Okay, so then then we have multiplication. What's negative 2 times 0? Nope. No, what's 1 times 0? I'll do it over here. 1 times 0. What's 2 times 0? Yeah, that's the property of 0. You put any number and multiply it times 0. What's negative 2 times 0? Yeah, 0 is your answer there. Plus 2. What's 0 plus 2? Yeah, when you add to 0, hold on, I messed that up. When you add, it's an identity property. You just get whatever number you identified. So you have 2 here, and then you have f of 6 here. And so that is your, this is your vertex. So let me write this down. It's good to write your, label your work when you're doing things. So that when you look back, you're like, oh, there's the work I did to find the vertex. There's the work I did to find the line of symmetry. Here were the zeros. In fact, we didn't even do the zeros here. There's a lot of work to find the zeros. The work to find the zeros is all over the place. But you could have done that. You could have just put, this is the work to find the zeros, and then, you can label, especially if you're on the same piece of paper. So, yeah, your vertex is going to be, your x was 6, and your y was 2. So your vertex is at 6, 2. And then I always like to, when I'm doing this, I like to label, okay, what crucial, points on here? I need to have the zeros. I need to know the vertex. The next would be the y-intercept. So now I'm gonna go up here and I'm gonna label this really quickly. I'm gonna label the vertex. I'll do it in green. So I'm gonna go forward to 1, 2, 3, 4, 5, 5, 6, and then I'm gonna go up to 2. So here's 2. There's my vertex. And then if we were doing a really great job, we would actually label it, and then, but it didn't say label. But if we were being all perfect and everything, we would label it. And then I can tell you right now that this is going to do something like this. It's going to graph down. But right now I only have 3 points, and it wants 5. Okay, so we need one more point, and then we can just reflect that point back across. Okay, so I would want to know where the y-intercept is when y equals 0. And so that's another one that we need to know. So I can come up here and I can put a little space. The y-intercept is really important. Okay, we want to have the y-intercept. And so the y-intercept is when x is 0. And so the y-intercept is when x is 0. Okay, so in this case, it's going to be not f of x, but f of 0, okay, equals, and then whenever you see an x, you plug in 0. So this is 0 minus 6 squared plus 3, okay, and so then you just do the math. What is 0 minus 6? Minus 6. Nope. 0 minus 6 is negative 6. Okay, so I'm just going to move ahead because I'm running out of time, and we're going to have to jump off this meeting in a couple seconds, okay? So then a negative 6 squared, that's 36. Okay, so we're dealing with a big number now. And so I'm just going to keep moving down. And negative 2 times 36 is negative 72 plus 3. And that's going to give me 69. And so my vertex is my y-intercept is down below here. And, it's going to be down here at negative 69. So it'll be like it's going to be way down there. And then if I wanted to, I could find the 5th point by just mirroring it. Okay, I got to jump off. And we would, at that point, we would be able to draw the graph. Okay, if we wanted to draw the graph, it would look something like this. But then our 4th and 5th points would be off our graph, like our y-intercept. Okay, then this line of symmetry comes down here, and I could reflect the other point over here. Okay, Okay, I got to get off, and thanks for